Yesterday we discussed about isotopes, isotones, isobars, isodiapers, isosters. Okay, we are in a few examples. One more. I'll try to say the answer for this. If number of protons in, if number of protons, if number of protons in x minus 2 is 16, then number of electrons in x plus 2 will be. Here the question is the number of protons in x minus 2 is the 16. X minus 2 16. The number of electrons in x plus 2 how much? Okay, Akshay. Vaibhav Surya correct only. Yes. Yes, actually the number of protons are 6. Okay, now 16. That means this x atomic number 16. So its plus 2 is nothing but it's actually the neutral atom, the number of protons equal to electrons. But here x plus 2 is nothing but it loses 2 electrons. So that means it's having only 14 electrons. Okay now. $14. And one more question, last one. Assuming that atomic weight of atomic weight of C12 is 150 unit from atomic table. 150 unit from atomic table. Then according to this, according to this, assumption the weight of O16 will be here assuming the atomic weight of C12 is 150 units. Then assumption the atomic weight of C16 according to this. Shall I? Right. Arshit Sai. Yes, listen. యాక్చువల్లీ ఏం లేదమ్మా, ఇక్కడ C12 కార్బన్ ని 150 యూనిట్స్ లాగా తీసుకుంటున్నారు. ఓకేనా? ఓకే. సో దే 12 AMU, C12 AMU that equal to 150 units. 12 AMU that equal to 150 units. Then 1 AMU how much? 150 by 12. Okay, that means 16 AMU. 150 by 12 into 16 అంటే 1 AM ఎంత వచ్చిందో that much into 16. Yes or no? We will get 200 AMU. Did you understand, everyone? Is it clear? Actually they are saying, assuming that atomic weight of C12 is 150 units, C12 ను 150 అనుకుంటున్నాడు. అంటే C12 AMU it equal to 150 AMU. That means what is the O16? ఓకేనా? what is the atomic weight of O16? అంటే ఇక్కడ ఏంది, actually 12 AMU that equal to 150 units, then 1 AMU equal to 150 by 12. That means total 16 కావాలి కాబట్టి 16. Okay, so 200 AMU. All right, I am removing this one. Next concept, subhead, next heading, I am removing. Electromagnetic waves. Electromagnetic waves, or we can write EM, electromagnetic waves only, or radiant energy. Or radiant energy. Radiant energy. Now, electromagnetic waves, which is very easy and simple. According to this theory, the energy is transmitted from the energy is transmitted from one body to another. One body to another. In the form of waves. Then energy is transmitted from one body to other body in the form of waves. And these waves travel in the space. And these waves travel in the space These waves are travel in the space with the same speed, with the same speed, same speed as a light. Do you know the light speed? Speed of light. 3 into 10 to the power of 8 meter per second. Okay. These waves are called electromagnetic waves. These waves are called electromagnetic waves. Is it clear? According to this theory, the energy is transmitted from one body to another body in the form of waves. And these waves are travel in the space with the same speed with the light as a light. 3 into 10 to the power of 8 meter per second. Okay. These are called electromagnetic waves or radiant energy or radiant energy or radiant energy. Okay. Example for this electromagnetic waves are radio waves, radio waves and microwaves, radio waves, microwaves, infrared rays, IR, infrared, visible rays, visible, visible rays, ultraviolet rays, UV, ultraviolet rays, and X-rays and gamma rays. Okay, did you understand? Simple enough. For example, if any body propagates in the space, it produces waves like this. These waves are called electromagnetic waves or radiant energy. Okay, these are travel in the space with the speed of same speed of light as 3 into 10 to the power of 8 meter per second. Okay, and now write a few important points. Here the first one, the radiant energy do not need, the radiant energy, the radiant energy do not need any medium for propagation. Do not need any medium for propagation. The radiant energy have the radiant energy have electric and magnetic fields, electric and magnetic fields, electric and magnetic fields, and travel at the right angle to this field. Okay, when 1 minute. The radiant energy have the electric and magnetic field. They travel perpendicular to each other. Travel perpendicular to each other. each other. Okay. And next, the uppermost point of the wave, the uppermost point of the wave, the uppermost point of the wave is called crest, is called crest. And the lowermost point is called trough. And the point is called lowermost point is called trough. Okay. So actually this is the wave. Okay now. This is direction of propagation amount. Direction of propagation. It produces waves. Okay. This uppermost point is called crest. This I think. This is trough. Okay now. Actually, any medium, if it propagates in the space, it produces waves, right? And it produces one more, electric field and magnetic field. Both the waves are present in this. This is one is electric field and other one is magnetic field, like this. Okay. Other will be electric field and other will be magnetic field. Both occurs in electromagnetic waves. Electric field will create the magnetic field. This electric field creates the magnetic field, and magnetic field creates the electric field. Okay. And now noted this one. Actually, did you understand this one? Any medium, any body propagates in the space, it produces waves. The upper point is called crest, and the lower point is called trough. Okay, na? These are the important points. The radiant energy do not need any medium for the propagation. The radiant energy have the electric and magnetic field travel perpendicular to each other. And the uppermost point of the wave is called crest. And lowermost point of the point is called trough. Okay, crest and trough. Okay, now the energy is transmitted from one body to another body in the form of waves, and these waves travel in the space with same speed as a light. These waves are called electromagnetic waves or radiant energy. Is it clear, everyone? Now some characteristics of electromagnetic waves. I am removing this one. Is it clear? Shall I remove? Today I will check your this atomic structure notes also in classroom. I have to know how many are writing. Okay. And next, characteristics of electromagnetic waves. The electromagnetic wave characterized by some properties. In that, the first one, wavelength. Wavelength. These all definitions will come in physics also. That is representation lambda. Wavelength. Simple. It is defined as the it is defined as the it is defined as the distance between distance between distance between two nearest crest or trough. Two nearest crest or trough. Okay, for example, these are waves. So here crest, the distance between two nearest crest are trough. Yeah. This is crest. The distance between two nearest crests are called wavelength, or the distance between two nearest trough are called wavelength. Okay, lambda. It is measured in terms of this wavelength measured. It is measured in terms of angstroms. Angstroms. Angstrom and PM, picometer, and NM means nanometer, and cm, centimeter, and meters. Okay, actually 1 angstrom equal to how many meters? 1 angstrom equal to 10 to the power of minus 12 meters. Sorry, 1 angstrom equal to 10 to the power of minus 10 meters. And 1 picometer equal to 10 to the power of minus 12 meters. 1 nanometer equal to 10 to the power of minus 9 meters. 1 centimeter equal to 10 to the power of minus 2 meters. Okay. These are representation measured in the terms of angstroms, picometers, nanometers, centimeters, and meters. 1 angstrom equal to 10 to the power of minus 10 meters. 1 picometer equal to 10 to the power of minus 12 meters. And 1 nanometer equal to 10 to the power of minus 9. And 1 centimeter equal to 10 to the power of minus 2. So did you understand the wavelength, the distance between two nearest crest or trough? The distance between two nearest crest or two nearest trough is called wavelength. That's it. Okay. And next, wave number. Next, second one, wave number. Wave number is represented nu. Sorry, wave number is represented nu bar, not nu. Nu bar. Frequency is nu. Nu bar it is the reciprocal of the wavelength. reciprocal of the wavelength. That is number of waves. That means that is number of waves, number of waves present in unit length. Number of waves present in unit length. The number of waves present in unit length. So the wave number, the new bar equal to reciprocal of wavelength, nothing but 1 by lambda. Is it clear? For example, these are waves. These are waves. Okay. The distance between two crest or trough are called wavelength. For example, from here to here, wavelength, we are assuming 1 meter. Okay, now 1 meter. So in 1 meter distance, how many number of waves are present in that? That is called wave number. అంటే ఈ 1 meter length లో ఎన్ని waves ఉన్నాయి? 1, 2, 3, 4, 5, 6. So that is called wave number. అంటే it is the reciprocal of the wavelength. The number of waves are present in unit length. That is called wave number. Okay, now nu bar equal to 1 by lambda. Why? Because reciprocal of wavelength. Okay, it is measured in the term of it is measured in the term of ఏమవుతుంది యాక్చువల్లీ ఇప్పుడు మనకి సెంటీమీటర్స్ మీటర్స్ లో తీసుకుంటాం 1 by సెంటీమీటర్ అంటే ఏమవుతుంది సెంటీమీటర్ ఇన్వర్స్ ఆర్ మీటర్ ఇన్వర్స్ ఎక్సెట్రా ఇప్పుడు 1 by సెంటీమీటర్ అంటే ఏమవుతుందమ్మా దట్ ఈక్వల్ టు సెంటీమీటర్ ఇన్వర్స్ ఓన్లీ a 1 by meter that equal to meter inverse. Is it clear? Everyone, wavelength and wave number. Shall I remove? Wavelength lambda, wave number nu bar. Now we are going to discuss about the frequency. I am removing this one. Frequency. Frequency. That is nu. Nu. Frequency is nothing but the number of waves. The number of waves which pass through a point in 1 second. In 1 second. In 1 second. It is measured in term of Hertz. HERTZ, Hertz. Or cycle per second. Here the 1 Hertz equal to 1 second inverse. ఇప్పుడు this one is propagates in the space. Obviously, it produces waves. Okay, these are producing waves, right? The distance between two crests, the distance between two nearest crests are called wavelength, or two nearest trough are called wavelength. The number of waves are present in for unit length is called wave number. Here and one more, the number of waves are passed through a certain point. ఇది ఒక పాయింట్ నుంచి the number of waves are crossed through a certain point, passes through a certain point in 1 second. అంటే 1 second లో ఈ పాయింట్ నుంచి ఎన్ని వేవ్స్ అయితే పోయినాయో దాన్ని మనం ఫ్రీక్వెన్సీ అంటాం. The number of waves are passed through a certain point. The number of waves are passed through certain point is called frequency. ఎన్ని వేవ్స్ అయితే పోయినాయో దాని మొత్తాన్ని మనం ఏమంటాం? ఫ్రీక్వెన్సీ అంటాం. ఓకేనా? Is it clear everyone? Next, time period. Next, time period. Time period. What is the meaning of time period? Time taken by wave to pass through one point. To pass through one point. అంటే ఒక పాయింట్ నుంచి మనం వేవ్స్ పంపడానికి ఎంత టైమో దాన్ని టైం పీరియడ్ అంటాం. That is time equal to one by v second. Velocity, speed. నెక్స్ట్ వెలాసిటీ అమ్మ. అంటే ఇప్పుడు టైం పీరియడ్ అంటే ఏం లేదు, ద టైం టేకెన్ బై ది వేవ్ టు పాస్ త్రూ వన్ పాయింట్. ఒక పాయింట్ నుంచి మనకు వేవ్ ఎంత అయితే వెళ్ళడానికి టైం తీసుకుంటుందో దాన్ని టైం పీరియడ్ అంటాం. ఫర్ ఎగ్జాంపుల్ 1 second, 2 seconds, లైక్ దట్. నెక్స్ట్ కీప్ ద హెడ్డింగ్ వెలాసిటీ. Velocity that is represented in C. Okay, this is before page. Next, velocity. Velocity of a wave. Velocity of a wave is defined as distance covered by a wave in 1 second. In 1 second. Well, session end అయితే will continue tomorrow. No problem. From velocity, we will continue from tomorrow.